right. So greetings, good afternoon, everyone. Welcome to TechGlamLIVE. I am Joe Mejica.
And I'm Doreen Pepers. And today I have a very special guest with us, Mr. Vader. He came to join TechGlamLIVE because he's super excited about learning about IWO and all the feature benefits that it offers. So everybody say hi to Vader.
Hello, Darth Vader. How's it going, man? So before I swing this around and possibly chop my head off, because we all need a head on our shoulders to learn about today's content, we have two special guests, Bobby Cooper-Smith, our cloud captain, and our Jedi Master, Michael Galligan. Thank you both for joining our call today.
And I'm super excited that we're going to be talking about Intersight Workload Optimizer. A big difference between traditional monitoring tools and IWO is that traditional monitoring tools only alert you on performance or utilization, but Intersight does both. It continuously analyzes workload consumption costs and constraints. But another cool thing to point out is that IWO supports not only UCS and HyperFlex environments, but also third-party infrastructures. IWO can pinpoint root cause for poor application performance, whether it's at the application layer, VM, or container layer, or even deep within your storage, compute, and networking environment. Plus, we're going to be giving away some great Cisco swag by way of Cloud Trooper Speed Test. The challenge will test your Intersight knowledge. And at the end, Michael and Bob's presentation, they're going to be so awesome at giving you this information that I'm sure everybody's going to be ready to show off their smarts. So, hey, Joe, can you tell everybody about the Full Stack Trilogy and our upcoming episodes?
Of course. So the Full Stack Trilogy is TechGlamLIVE's three-part webinar series where we talk about Cisco's full stack observability products. Last month, we talked about Thousand Eyes. Today, we embark on a journey to talk about IWO. Next month, we enter the final part talking about AppD. So as we embark on this new galaxy of multi-cloud, hybrid, etc., with a lot of these moving pieces in our workloads, the importance of our applications across our respective missions, today's mission is for us to learn about these tools. So get back, strap up, and we're going to have a really awesome show today.
That sounds really cool. I'm pretty excited about this. So let's hear from Bobby. Bobby, tell us more about IWO.
Sure. Sorry, I was on mute there. So Intersight Workload Optimizer, it's a very, very unique, interesting platform, right? What it mainly focuses on is helping you assure application performance, right? Now, what that looks like is specifically focusing on the resourcing side of things, right? So what kind of knobs and levers do I need to pull in my data center, whether that be on the app level, on the VM level, on the host level, on the storage level, on the container level, right? What kind of adjustments do I need to make in real time to assure that I have exactly the right amount of resources and not too much, not too little, right? So really automating two aspects, the decision-making process of figuring out what exactly to do, why to do it, and when to do it, as well as the action itself of making that change on behalf of customers.
And Jedi Master Michael, just curious, I want to know, what is your take on IWO? What is it to you?
So where IWO really comes together in the full stack visibility story is on that infrastructure layer. As we've talked about throughout this trilogy and continue, we're focused on driving a positive application experience for our customers, regardless of where those applications live, in a private data center, in a colo facility, or in the public clouds. We want to make sure that our customers and their internal employees who rely on these applications to run the business have a superb application experience. So what are some of the things that go into that application experience? Well, it's everything we're talking about throughout this trilogy. It's the code. It's the code that's running on, that's running on-prem or in the cloud. It's the network. It's the connection to an ISP. Or it's the back-end infrastructure that is actually supplying the necessary resources in terms of storage and compute and memory. And this is where IWO comes in. As Bobby mentioned, this essentially provides you with application assurance at the resource level to get your workloads what you need, when you need them, at the lowest possible resource cost. I mean, who wouldn't want great performance at a low cost? That just seems like a no-brainer to me. So I think today is going to be a great session because I think for a lot of folks, this is a solution that could solve a lot of issues that our customers are facing in terms of cloud cost containment, migration plans, but essentially end the firefighting challenge that a lot of customers face and the reactive operational cycles that they face. So that's why I'm excited about this technology. That's why I think you guys will too.
So I hear the term costs, right? And I don't know, like I went to school at one point in my life and I took an economics class. Does economics and cost really have to do anything with today's solution today, Mike?
Yeah, so it's funny you say that. So if you guys can think back to the days of high school or college when you took Econ 101, in Econ you have a marketplace where you have buyers and sellers. And if you recall, where the demand for a market meets supply is called equilibrium, where those two lines cross. And in economic theory, that's the sweet spot. That's where economists want every market to go to, is that level of equilibrium. That is essentially what IWO is doing for customers. It is abstracting your environment, whether it be on-prem, in the cloud, wherever, into a marketplace. Only difference is that your buyers in this case are your workloads. They're your VMs, they're your containers. And your sellers are your private data center, your public cloud provider, or anything else, or any other environment that's serving up excuse me, any resources to them. So the result is that your applications, like I mentioned earlier, get the right amount of resources when they need them. So you maximize your ROI on your current investment in resources, servers, storage, cloud instances, only with higher performance.
How does IWO show customers how it matches resource supply with demand? Can you talk a little bit about how IWO has that intelligence built into it, where it understands the resources that are being used and how it can save customers money and match that resource supply with demand?
So the process to get IWO going it doesn't take very long, or is not overly complicated. It doesn't rely on customers to set static benchmarks. It's completely API driven. Once IWO is running in the environment, it begins to learn about the environment and do discovery. And then it constructs that marketplace I was referring to earlier. After it learns, it will actually make actionable recommendations that you can take to improve performance, increase density, or save you money in the public cloud. You'll see in Bobby's demo what these actions look like. But the really cool thing is that you can either manually execute these recommendations, so you can see what IWO is saying, like, hey, take this action, and you can say, yeah, go ahead, IWO, do it. Or you can actually let the software execute that recommendation for you without any intervention. So the net here is that it saves customers time and improves the user experience while saving costs.
Wait, so you're telling me machines, managing machines? Like, how does that work? Like, that doesn't sound right. It sounds like Terminator. Like, we're talking about Star Wars today, but then all of a sudden we're bringing in like a whole other franchise. Like, what's going on here?
Yeah, it's machines managing machines. Now, yes, Joe. Before you get images of Skynet from Terminator, or the Death Star from Star Wars, to keep with our trilogy theme here, our customers can put policies in place within IWO that allow them to put guardrails on what decisions are or are not automated. These can be things like where automation can take place, what data centers. You can also set guardrails in terms of what workloads and when they can be executed, like outside of like a maintenance window, within a maintenance window, for example.
So let me ask you this. There's a lot of tools out there as far as monitoring tools, right? And I'm sure everybody has their favorites. How is Intersight Workload Optimizer, how is that any different from any other monitoring tool that's out there?
I mean, that's a great question. So let me answer that with a question. What happens to our customers when they get an open ticket or a complaint that an application is quote unquote slow? That's typically when they go into these tools to do troubleshooting. They enter war rooms, and then it turns into a game of mean time to innocence. Oh, it's not the storage, it's not the network, it's not, it's not the code itself. What IWO does and what makes it really different is something that Bobby mentioned earlier, is that it will make these recommendations for you on the fly so that it tells you what you need to do to avoid having the ticket open in the first place. It's a dynamic decision engine. It's not a monitoring tool. It's a dynamic decision engine that assures application performance. And that's really what makes it unique in the marketplace.
Okay, that makes sense. So I think one thing I'm really curious about, so we hear Cisco talking about full stack observability. Obviously, you look at Jenga, you think of an ideal stack as one thing, stacking on top of the other, and it all comes together as one cohesive piece. Obviously, you play Jenga, you pull things apart, may fall apart, but obviously this isn't going to fall apart, right? So my question is, how does this really fit in and tie together with AppD, Thousand Eyes? Like, how does that all really come into play here?
No, it's a great question, and I think this is where it gets really cool. So like I said in the very beginning, right? Cisco, we have our full stack observability that allows our customers to see the user journey, through the eyes of Thousand Eyes in the network, AppD with the code, AppD from a code perspective and a business impact perspective, and then the topic of today, IWO. So with IWO in particular, the more data you feed into it, the better the solution gets. So for example, if you were to integrate AppDynamics' capabilities and its understanding of the application line of code, application code itself into IWO, now you're able to correlate business outcomes, application visibility, and performance with infrastructure metrics to provide that full stack observability. At the end of the day, I think it's pretty simple, right? Why do applications break? The network, there's a network problem, there's something wrong with the code, or the infrastructure has issues on it. So by combining all three of these elements, Thousand Eyes, IWO, and AppD, really does cover our customers in all three and delivers that full stack observability. So that's how all the pieces come together, and that's, to your point, Joe. That's how the Jenga tower stays fully up.
Totally makes sense, Mike. Thank you for that. Any other last minute thoughts before we jump into the demo? Any other last minute additions you guys want to add?
No, I think we've kind of talked enough. I'm a big believer in seeing it in action, and we hope that you enjoy the demonstration. But for the remainder of the time, I'll kick it over to Mr. Bobby to show us the tool.
Awesome. Let's do this.
Thank you, everybody. And give me 1 second. I'll go ahead and share out my screen. Can you guys see it?
Yep.
Cool. Awesome. So this is the awesome IWO interface that we're looking at, right? And before we jump into all these, colors and different diagrams and recommendations that you see here, I'll just talk a little bit about setup, just so everyone is clear how to get this thing up and running, right? But long story short, this is a SaaS offering, right? So the only thing that you need is a Cisco ID to obviously log into the UI. And then in order to get the data collection started, it depends on what your environment is, right? So if we're talking about an on-prem environment, one of the first things we're going to need to do to get this thing up and running is deploy a appliance called Intersight Assist, right? And what that basically is a VM that we would spin up in your vCenter environment, and that would be our secure way into your vCenter and our secure way of communicating with your vCenter server, which will allow us to pull in all the information as it relates to your vCenter environment. If we're pointing at things like AWS or Azure or AppDynamics, right, it again depends on whether it's a public-facing instance like Azure, AWS, or something private. But long story short, you just point IWO in the right direction, and you provide it with the necessary information it needs. So, for example, from a hypervisor standpoint, if we're talking about VMware, it's giving us access to things like the IP, right, the credentials associated with a service account that will allow us to read and pull in the data we need to. And as long as you have all this done and you hit claim, your job from a setup standpoint is pretty much done, right? There's no thresholds that you need to configure, right? There's no additional policies that you need to build out in order to start to get some of these recommendations. What's going to happen next is IWO is going to start to build out this diagram here on the left. And what we call this internally is the supply chain. And why we call it the supply chain is because essentially it is a map of how resources, whether they be infrastructure resources on-prem or cloud resources, right, how resources are eventually supplying the layers above themselves in order to meet the overarching demand of the business application, right? So we map out this full supply chain so we get a full relational understanding of who's consuming resources from what, right? Which VM is on which hosts, which applications are running on which VMs, is that VM in the cloud, is it on-prem? And then we start to collect utilization metrics around how resources are being consumed at every single one of these layers, right? How something like response time is interacting on the app level, right? How something like heap utilization might be affecting the JVM application, whether that be running as a VM or running as a pod, right? How memory and CPU might be behaving on the VM level, how throughput might be behaving on the host level, and latency on the storage level, so on and so forth, right? But the magic of IWO isn't really the data it collects or the pretty pictures or diagrams that it's able to deliver as a result of its understanding. The real value is what we do after we have the data, right? Because that's really where every monitoring solution stops, right? Typically, they give you data, they give you pretty pictures, and they say, here's the problem, you go figure it out, right? The benefit of IWO is we take that data, we run it through our decision-making algorithm, which, as discussed earlier, is founded on economic principle, and we output what really matters, right? Which is, what kind of actions can I take right now to drive my environment to a more resilient, more cost-effective, and just overall more optimized state, right? And those recommendations that you're going to get out of IWO are going to focus on a few different categories, right? They're going to focus around moving resources, right? Maybe that be something like moving a virtual machine from one host to another to alleviate something like ready wait time that we can experience on-prem, right? And we might be thinking to ourselves, well, doesn't VMware have something that does that? I think it's called DRS or Hyper-V or whatever hypervisor you're on. Is there some kind of built-in load balancer? And the short answer is absolutely. But the difference between a load balancer and IWO is the fact that we're trying to assure performance. And what that means is we don't look at things in isolation. And this is the key theme and differentiator between IWO and everything else out there, right? So when you take a look at something as simple, or what seems as simple as moving a virtual machine from one physical machine to another to alleviate something like ready wait time, which is a single area of bottleneck, it's really not that simple, because you really got to look at the entire picture, right? Sure, you want to alleviate this risk point, but you also don't want to alleviate this risk point at the expense of creating another bottleneck elsewhere, right? And unfortunately, that's what most load balancers traditionally do. They will focus in on one single metric, whatever is most utilized or most at risk. But since IWO's approach is really around assuring the overall performance and optimization of the entire infrastructure as well as the application, we're really taking this entire picture into consideration as a holistic entity, right? Meaning we are not just looking at CPU without also taking into consideration the ramifications that this action might have from a memory standpoint. And same thing goes when it comes to things like sizing, right? Making a recommendation or coming up with a decision to go from 4 to 5 vCPUs on a machine probably does not seem that difficult. But when you backtrack and you think about how customers traditionally do it today, it's a much more reactive process and it's extremely time consuming. Because today, without IWO, the process would probably look something like this, right? I get an alert that says, hey, Jamie T8 TD Bank is running at higher utilization levels than I want. I might drill into this virtual machine. I might pull up a chart similar to this virtual machine resources chart, where I might pull in things like the peak metrics and the average metrics, and I might pull it back 30 days. And I might come to a similar conclusion like IWO, where I say, okay, this machine needs more CPU. Great. That is only the first step of the entire process, right? Because even if I know that I want to give more CPU to this machine, if I'm trying to make the best decision possible for everything, I have to really look at the underlying physical machine as well. right? Because if this physical machine is already heavily utilized from a CPU standpoint, or maybe more utilized than it needs to, then taking that decision that I showed earlier, where we're trying to increase the CPU capacity of one of those VMs, is probably going to create more problems than benefit, right? Because now we're actually instilling a bottleneck, a layer beneath us, which in this case will affect 22 additional virtual machines, right? So again, the beauty of the IWO platform is regardless of whether it's making its decisions as it relates to the virtual machine level or the host level, it's really always taking the entire picture into consideration. That way, when you do get a recommendation that says, hey, you need to do this, right? Hey, you need to increase this machine or move this machine, it's with full confidence that we are not going to put anything else at risk, and the end result is going to be a net positive impact on not just the infrastructure, but also the overarching application. Now, what does this look like if we talk about public cloud, right? Because I'll be honest, everything I've kind of showed you today so far has been what we can do in an on-prem environment. When you talk about public cloud, the same type of complexities exist when it comes to trying to float that equilibrium and make sure that performance is met without necessarily overspending your way around it, right? And certainly in the public cloud, there are probably less knobs that you have to pull, right? There's no physical machine that you have to keep an eye on. There's no physical hardware that you need to try to maintain. But what you are tasked with is continually pattern matching your workloads and the application demand that they are feeling with all the different configuration options that exist in the public cloud. And when we take a look at that, I like to pull this tab up just to give everyone a quick idea as to how many options exist. There is a ton, right? This is just how many instance types exist in AWS. And unfortunately, in the cloud, we don't get to pick and choose anymore, right? We have to pick across these different offerings to figure out, oh, maybe I should run an M5D extra large because I need 16 gigs of RAM, 4 vCPUs, and all these other things, right? But to cross-reference this catalog every single time, mind you, keep in mind that this is continually getting updated as AWS and Azure release more instance types. That alone is a full-time job. Keeping track of that and pattern matching it with what your virtual machines are doing is honestly almost impossible if you get to a certain point of workload, right? But when you have something that already natively understands the demand of your applications and can already natively run decisions and run analytics to figure out what the trade-offs are between performance and efficiency and output for you, intelligent resourcing decisions, it's really easy for IWO to do the cross-referencing on your behalf, right? And output, again, what matters, which is decisions around what to do, why I should do it, why it's going to help me, right? And when I should execute that decision, right? So for example, you've got a recommendation here that says, hey, you should actually scale up this Ubuntu Web 01 server in this pay-as-you-go subscription from a standard S8 to an F16 SV2. And interestingly enough, what we're doing here is if you actually look at the utilization of this workload, you can see that we have relatively high CPU utilization, but relatively low memory utilization. And the tough thing about the cloud is if you stay within your instance family, you're typically going to double up on every single one of these resources. So if I was doing this manually, I might just say, okay, go up to the second biggest instance type above a standard F8. Sure, that will absolve my CPU risk, but that's also probably going to give me more memory than I really need because I'm already at 16%. I'm only at 14%, so do I really need more? So I was able to intelligently understand, in this case, what we actually need is CPU, not necessarily more memory. Let's maybe roll over to a more modern instance family, which is going to be a little bit cheaper than this deprecated one anyways, or this older one anyways. And this will allow us to get the CPU we need at probably a lower cost than if we were to stay on this instance family, right? So again, it's about taking the entire picture into consideration. That way, when we output you decisions around scaling up, scaling down, maybe buying some reserve instances, it's with a full understanding as to what is going on. Let me pull up some scale down decisions, right? This is a scale down decision. So again, whether it's scaling up or scaling down or recommendations around, which reserve instances to buy, it's with a full understanding as to exactly what your environment is doing, what kind of demands are needed at various areas. and what the best course of action or adjustments are needed to meet that demand and to meet those adjustments in the most cost-effective and performant way. Now, I've mentioned a lot about infrastructure, adjusting resources on the infrastructure level. I've also mentioned the application, but I haven't really delved or jumped too much into what it actually looks like when we bring the application in. So let me touch on that real quick. So as Mike mentioned, we do have the ability to tie into the application layer, and this is where, as mentioned, it gets really cool, right? Because rather than just looking at the virtual machines, which is certainly helpful, as mentioned before, there's a lot of cross-referencing that typically needs to be done, even if you're just looking at things on the virtual machine level. And the fact that IWO can do that on your behalf is immensely valuable, right? But now, when you tie in the business app, this platform gets even more intelligent. Because now we're going to start taking into things, start considering things like response time, right? We're going to start to consider things like your transactions. We're going to start to consider things like your garbage collection time on the application level, right? What every single one of these application components is actually doing. And the benefit of this is so that IWO can, again, complete the entire picture, right? Because we obviously all know there are situations where, hey, maybe a virtual machine is behaving a little bit erratically to no fault of the application. Or maybe there are situations where we're talking about a SQL database that looks like it's slammed, but in reality, the SQL server itself is just fine. Without understanding and without exposure into the app level, it makes making that decision a little bit more difficult, right? But by being able to complete the picture and allow IWO to look at this entire stack from the app level all the way down to your infrastructure, now you get true application awareness where we are taking things like heap, thread, response time, garbage collection, transactions per second, and marrying that to our understanding of your virtual machines. That way, when we output any recommendations, and I know that I don't have any in this example, but that way, if we output any recommendations around the sizing or the adjustment of your VMs or your underlying infrastructure, it's with a full understanding as to the impact that's going to have on the app level itself, as well as if any other adjustments need to be made on the app level to ensure that you are taking full advantage of the infrastructure adjustments we have. Lastly, right, all of the things we've walked through so far today, the scaling actions, the placement actions, the delete actions, all this good stuff, once you actually trust the platform, you can kind of take your hands off the wheel, right? So rather than coming in here and having to manually approve these actions and say, hey, yeah, I'm okay going from 4 to 5, or I'm okay going from 8 to 9 and wasting my weekends away clicking in the platform, once I actually trust it and trust the decisions that are coming out of it, I can just set up an automation policy, right? And this is where you get that machine managing machine analogy that Joe was talking about earlier. The long story short, I can go in here and say, you know what, I'm tired of having to click and action things off. Let me just institute a resize up window, and I want IWO to just take care of it for me. So I can go in here and say, hey, from now on, every time there is an opportunity to size something up, I would actually like you to just do it on my behalf. Right? If we want to actually split out the execution of the action from the acceptance of the action because maybe it's disruptive, like sizing down, we can do that as well, right? So we can create a schedule in here. Looks like it's just refresh real quick. So if I just go back to policies, 1 second, guys. So if I just go back to the policies and I just pull up that execution schedule again, the cool thing about IWO is that you can actually split out that acceptance from the execution. That way, throughout the week, if you wanted to, you could go ahead and queue up whatever it is you want to get executed. And then rather than having to go in here in the weekend and do it yourself, right, you could just build a schedule and say, hey, IWO, I'm going to queue up a bunch of the recommendations you've given me. And I would like you to always execute anything I have queued up on a weekly basis on Saturday between the hours of 6 p.m. and 8 p.m., right? And if I put this execution schedule in place, you no longer have to go in here and execute anything, right? You just have to queue things up, accept them throughout the week as you go about the day. And when that window rolls around, I will go ahead and carry out those actions for you. The last thing I'll touch on is what we can do from a simulation perspective. So everything I've talked about so far is how we can help when it comes to real-time management, right? Adjusting resources on the fly, right? Sizing something up, sizing something down, moving something over to a different resource provider, right? At some point, you're also probably going to need to make decisions in the future around what if I do this, right? Or what if I move a bunch of workloads into the public cloud? What is that going to look like? How much is it going to cost? Since IWO already natively understands how everything eats, sleeps, and breathes in your infrastructure and how they consume resources, it's really easy for us to also simulate any changes, right? So whether you want to simulate a hardware refresh, whether you want to simulate a cluster merge, whether you want to simulate migrating a virtual machine from one cluster to another, or maybe you want to simulate a migration to the public cloud, you can do all of this in a couple clicks rather than a couple hours or a couple days in Excel, right? So if I wanted to, I could just say, hey, you know what would it look like if I moved this entire cluster into Azure, right? Or if I wanted to pick AWS, I could pick AWS. And then I would just pick a region, and I would hit Run Plan. And if you just give it a couple minutes, what you're going to get is a very interesting output, right? Because you'll get a full analysis on what it would look like to lift and shift, where your optimization opportunities may exist, right? And as you can see here, the output tells you exactly that. The lift and shift column is exactly what it sounds like, right? If I just take these 58 virtual machines and I put them up into Azure and I try to find the best instance type available for these machines, what would that cost me? In this case, around $2,364. If I optimize these 58 machines for compute and for storage, and I'm more intelligent about what I prepay for and what I commit to, right? What could I get that spend down to? In this case, it's only $888 a month, which is a 62% drop. And although this calculator is helpful and probably eye-catching, right, the biggest value here isn't the fact that we can come up with these numbers for you. Because even if you were able to come up with these numbers, the hard thing is figuring out how to actually get to this optimized state where you're only spending $888 a month, right? And since IWO is, again, at the end of the day, a decision engine, that's exactly what we're going to output for you along with the numbers and the aggregated value, right? So we will actually tell you how we went from $1,600 a month to $800 a month, VM by VM, right? So we will tell you, hey, this VC03 VM00, currently today, based on how it's sized on-prem, you'd probably be picking a standard F1S that's around $36 a month. In reality, what it's actually utilizing is a standard B1LS, right, which is only $3.80 a month. And if you want the justification, all you got to do is click on the Details tab, similar to our on-prem recommendations, right? And you'll see exactly the justification and the intelligence behind this decision. Same thing from the storage side, right? So again, the net here, guys, is whether you are trying to manage things in real time or whether you've got needs to plan things out in the future. You know, when it comes to resource optimization and figuring out how to properly align everything on-prem or in the public cloud to what your applications need, the only thing that can allow you to do this in a preventative way is IWO, right? Because we're keeping track of how everything is moving in real time, what they're doing, how they're affecting one another, and outputting and adjusting our decisions to reflect whatever real-time changes you have. That way, everything is contention-free from the storage layer all the way up to the app layer. That's kind of it for me in terms of a demo. You know, I'm happy to jump into anything more specific if there are questions. But that should give a general gist of what IWO is meant to do and where it delivers the most value. Thank you, guys.
Awesome stuff, Bobby. Hold on. Actually, I'm getting a quick little phone call here. Hello? What do you mean you couldn't make it to today's presentation? We talked about how much we can save money today on our apps and stuff. Yeah, we're waiting for you for a long time. All right. Hey, Doreen. I'll turn this off so I can see some power. Yeah, a couple of my fellow Jedi couldn't make it today. But how can they watch today's transmission so they can get caught up to speed before I start
before
using this?
Before you chop their heads off?
No.
So today's episode will be posted on my YouTube channel, TechGlam TV. There you're going to find episodes of TechGlam Live and other videos related to Cisco. If you missed our last month's episode on Thousand Eyes, it's going to be posted on TechGlam TV real soon. So the best way to find out about latest releases and videos that are released and uploaded, you need to subscribe to the channel. And then that way you'll get notifications when all these videos are released. So stay tuned, subscribe, and then you'll get a notification on this video. It looks like we've reached the end of our show.
Awesome. Once again, Bobby, Mike, thank you so much for taking the time and sharing your expertise. We look forward to having you soon, hopefully in the next episode or so.
Absolutely. Everybody join us next month for another fun-filled episode. We're going to be talking about app dynamics. I'm Doreen Pepers.
I'm Joe Mejica, and I'm about to go find some people.
Have a great day. Bye-bye.